Hi, everyone. Welcome to our session. If you're here to learn about the Daydream controller and how to design and develop for it, then, well, you're in the right place. We're going to be doing this session in 3 main chapters: how, why, and what. We'll dive briefly into the design of the controller itself. We'll then walk through the technical concepts on how to implement the controller support in Unity and C++. And then we're going to bring Ryan and Francisco on from Shell Games to share what they've learned and showcase over a dozen mini-games that they've built in the past few weeks that really help show what this new input device can do. So let's get started. Hi, I'm Bashir. I'm a hardware interface designer here on the Google VR team and the design lead for the Daydream controller. I'll be walking you through the first part. One of the most important things that we've learned from Cardboard, as you might have heard in our other sessions, is that while VR is great for gaming, and we've had so much fun with a lot of the games that we've played so far, we really believe that VR is going to be great for so many other things as well, and has a ton of potential as a computing platform. And that is what makes it such a compelling experience to a huge breadth of people. And for many of these people, the applications that you're building right now are going to be some of their first experiences in VR. And so the more we thought about that, the more we realized that we needed to build a better, more immersive, longer-form way for people to interact in VR that didn't involve them keeping their hand up here on their head on one singular button like they do with the more snackable experiences of Cardboard. So we made the Daydream controller. While it doesn't literally float in the air like it does on this slide, it is something that you can hold in your hand that we've been creating for our new Daydream platform to help connect people to their environment in mobile VR. It enables you to explore and manipulate things naturally in a 3D VR environment by letting you directly point at and click on objects, hold a tool in the virtual world, and navigate menus. We've spent a lot of time and energy in order to create something that is accessible and simple enough for new users and people of all kinds of interests that enables everyone to express themselves creatively, directly, precisely, intricately, and that doesn't force them to lug around something huge and unwieldy. The ultimate goal was a powerful, simple tool that fits right in your pocket. So let's start from the top. The Daydream controller has a curved, clickable touchpad that allows people to make both fine-grained manipulations and quick swipes for scrolling while still enabling them to make click selections without lifting their thumb. How does that work? Well, if you look closely at the side of the controller, we've achieved this by embedding a tactile, clickable switch directly beneath the touchpad that allows the top housing to elegantly flex when you apply pressure with your finger. And that's something that shouldn't be too unfamiliar for laptop touchpad users. Then, reachable just below the touchpad are 2 buttons, the Home button and the App button. The recessed Home button is reserved entirely for the system. Pressing it takes people immediately back to the home world, while holding it down for just a little bit longer lets them reorient their view. The App button, as you can guess from the name, has its functionality reserved entirely for app developers. For example, you could use it to enable switching from a hammer to a saw, more often than not to open up a menu, or in some cases, undoing a failed pancake flip. And since your phone is inside the viewer and audio is such an important part of VR, we've put hardware volume buttons directly in your hand to make it so that people can reach them conveniently and quickly. However, the most important and foundational aspect of the controller is its ability to directly point in 3D space around you. We use a highly calibrated 9-axis IMU that combines and fuses data from an accelerometer, gyroscope, and magnetometer to output an absolute rotation value in VR space. This means that instead of relying entirely on a touchpad to scroll through lists locked to your viewport, or turning your head in every direction to click on something, instead you just point directly at it with your hand and click. And because it's done on a chip, you can do that anywhere around you, be it straight ahead, to your right, or behind you. And all of that without having any need to lug around and set up an external camera or tracking system. And because this took both leaps in design as well as in hardware and software, we've been developing both in parallel as a team together. Here is one of our hacky early prototypes that we had been using in development, which, because of its similarity in its size, we lovingly call the garage door opener. And we and our various teams around Google had been using these to test and prototype a lot of our software and hardware stack. But As we got deeper into the project, we realized we couldn't just mail one of these to everyone out there, and we'd really love for both everyone here in person as well as every other developer out there to be able to intimately incorporate this input into your development process while creating your new VR apps. So Bruno, Zhao, and I, and a handful of others, found a scrappier, cheaper, and more accessible way. It's in your pocket. Most modern mobile phones today contain almost all the hardware you need to replicate the controller, minus the click. So we created an app, which you'll be able to download soon, called, shockingly, the controller emulator. And although the orientation sensors might not be as precise or as calibrated as in our final hardware spec, it should be a great alternative to get off to prototyping fast. So with a second phone, you'll be able to start up the app, which creates a hotspot, and connects to your viewer to broadcast its input in real time. And that said, because we're working in a VR world that's only tracked via rotation, you're essentially blindfolded while you're in there, and you're likely holding a phone that's way bigger than the hardware controller spec. So we've created a sticker overlay to help guide your fingers. It's capacitive, comes off cleanly, but still gives you just the right amount of tactile feedback to find the now real-size touchpad and buttons on screen. We've got printable PDFs for scissors and paper, as well as laser-cuttable vector files, and a link to the sticker material. And all of that will be in the SDK download itself, as well as online on our developer site. I've also got a batch of them pre-made with me, so after this talk, I'll be standing outside the tent if you want to come grab one or ask questions. And Bruno, in the next chapter, will show you how to implement the SDK and how to enable you to use both this emulator and the final hardware in your apps, and switching between the two should actually be pretty seamless and require almost no code change. But before I go, I wanted to leave you with a pretty simple question. With the Daydream controller, we're incredibly excited about the possibilities that you'll come up with. You could be holding a tennis racket, a whisk, a frisbee, a steering wheel, and so much more right in your pocket. So what do you make in VR? Thanks.
All right. In my section of the talk, we're going to be speaking a lot about code. But what exactly is code? Well, the way I like to think about it is that if on the left side you have the user, and say on the right side you have some abstract concept, say happiness, then the only thing that's standing between those two is the code that we write. So that's why code is such a big deal. But before we talk about code, let's go briefly into the things that you'll need to write code for the controller. So if you have the controller on one side and you have your phone on the other, how do these two things communicate? Does anybody have a guess? Bluetooth? Yeah, that's a great guess. Yeah, more specifically, it is Bluetooth Low Energy. So the phone talks to the controller via Bluetooth Low Energy, and your app is there sitting on the phone. Now, if you're not exactly the type of developer who wakes up every morning thinking, yay, let's write some low-level Bluetooth code, don't worry, you won't actually have to. You actually, because the Google VR Services is a layer on the system that talks Bluetooth directly to the controller so that your app doesn't have to. Instead, your app interacts directly with the Google VR SDK. And the Google VR SDK does all the hard work of actually communicating to Google VR Services and ultimately to the controller. The controllers are going to be available later on in the year. But if you want to start developing right now, you can. All you have to do is assemble your own dev kit. And your dev kit consists of a viewer. You'll also need a Nexus 6P as a phone. And you'll need to install the Android N Developer Preview 3 on that phone. Instead of a real controller, you can use a secondary phone as a controller emulator. So you need one viewer, and you need two phones. From the perspective of development, not much changes. You might be worried, oh, do I have to write code especially for the emulator, and then will I have to change everything? No, because the Google VR Services deals with the code that actually speaks to the controller. So in terms of SDK, it's the same thing. You don't have to worry about whether or not you're using the emulator or a real controller. Our SDK comes in several flavors. And you can go today to developers.google.com/VR if you want to get started developing right away. So you don't need to wait for the real controller. You can start right away today. Now let's talk a little bit about the features of the controller, which are common regardless of the SDK that you're using. The controller has 5 main features: orientation, gyroscope, accelerometer, and it also has a touchpad and several buttons. So let's go into a little bit of detail about each of those features. Starting with orientation, which is perhaps the most intuitive one. Orientation just means it's where the controller is pointing in space, in 3D space. We'd like to call it a 3-DOF controller, not only because DOF is kind of a cool word, but also because it means 3 degrees of freedom. And which 3 degrees of freedom are those? That is the yaw, so where you're pointing the controller, the pitch, also called elevation, and the roll, which is also called twist or bank. So those 3 angles are the 3 degrees of freedom of the controller. We represent those using a quaternion. And quaternions are interesting mathematical entities. In most cases, if you're using a math library or a game engine, you can treat them as a black box, or more specifically a blue box in this case, because they essentially encode a rotation that you can apply to a vector. But if you want to look inside a quaternion, it's not actually that hard. It has a vector component made up of x, y, and z. It also has a scalar component, and it has a 5th component. Does anybody know what the 5th component of a quaternion is? No? It's magic. Because that's the only way I can believe in how they work. Well, actually, at least that's what I thought in the beginning. But then as I studied them, I realized that the scientific truth is that they're only about 60% magic. The rest of it is not. We represent all of our coordinates in the right-handed coordinate system. So you have the x-axis pointing towards the right, you have the y-axis pointing up, and you have the z-axis pointing back. So this is just a standard textbook coordinate system. Next, we have the gyroscope. The gyroscope doesn't have anything to do with where the controller is pointing. It has to do with how it's moving. In particular, it encodes the angular velocity of the controller about each of its local axes. So just to give an example, suppose that you have the controller sitting flat on your table, and it's rotating counterclockwise slowly at 1 revolution every 2 seconds. So what would you read from the gyroscope in this case? Well, the x and z would be 0, because it's not rotating there. But about the y-axis, what would be the rotational speed in radians per second? If you guess pi, that is correct. Now, did I choose these numbers just to make this terrible pun? No, not in any way. That's a coincidence. The accelerometer, of course, measures the force of acceleration on the controller about each of its local axes. It is combined with gravity, just as on a smartphone. So normally, if the controller is sitting on your desktop, you're probably going to be reading something like 0, 9.8, 0, because the force of gravity is 9.8 along the y-axis. If you ever read 0, 0, 0, you should be concerned, because it means that the user is in outer space, where there's no gravity, or worse, that the user tossed the controller out the window and it's in free fall towards the ground. In which case, you might say, rage quit detected, would you like to play an easier level? Also, order me a new controller. Well, and lastly, we have the touchpad. The touchpad is that circular area at the top of the controller. It is a 2-dimensional surface, so we chose to use x and y very creatively to represent the position of the finger on that surface. In order to represent coordinates, we think of it as a square, and we map 0, 0 to the top left and 1, 1 to the bottom right. It's important to notice that the touchpad also has a clicker, so the user can both touch the touchpad and also apply some pressure on it to make it click. And those 2 things are different. And the buttons on the controller are the click button, which is precisely this button that the user presses when they apply pressure on the touchpad. And you also have the app button. The app button can be used by your app to do anything you want, like a menu or switching tools or anything else you want. We also have the home button on the controller, which is reserved for the system use. For example, that's how the user goes back to the home screen. That little thing on the side are the volume buttons, which is also reserved to the system. So the click and the app buttons are available to your app, and you can implement anything you want with them. Typically, clicker will be the primary action in your app, like painting, drawing, shooting, selecting, grabbing, or anything like that. And the app button will be some secondary action or to bring up a menu. So once again, touch is different from click, and this is a very important point. And on the emulator, since there's no such thing as clicking a touchpad screen, a smartphone screen, you actually double tap to emulate the click. And later on, we're going to give you like these little stickers that you can put on the controller emulator to get more of a tactile feel of how it works. Let's briefly go into the C++ SDK. Well, C++ is a great language. It's my favorite language. But the thing is, it's a powerful language that has some responsibilities that come with it. How does this sentence end? With great power comes great stack traces that you sometimes have to debug. But that's C++, and I like C++. Hopefully that won't happen to you. When your app is talking to our C++ API, it is actually talking to our C API that lives in libgvr.so. And the reason why we do a C API instead of a C++ API is because it's difficult to get two compilers to agree on how to compile C++. So instead, the C++ API lives entirely on your space, and it's just a wrapper around the C API. So you can use it without worrying about compiler API incompatibilities, which is good. Now let's look at code. If you have experience in C++, you're thinking, oh, that's a funny dialect of C++. But no, it's Java. It's because in Android, everything begins in Java. So on your onCreate function, first thing you're going to do is set the VR mode enabled, because that's going to enable all the nice VR optimizations for your app. Next, you have your GVR layout, what used to be called the cardboard layout. You set the presentation view as you are used to doing. And next, and this is the important part, you get the GVR native context. So the GVR native context is just an opaque pointer to a GVR context, which is something that you'll need to initialize the controller API. When you're down into the C++ land, all you have to do is get that pointer and then store it somewhere, because you'll need it while initializing the API. Speaking of which, after you set the default options, that's where you pass in the pointer on the init function. You pass the options and that pointer. And then you can forget about that pointer, because it's only really used to synchronize the controller and the headset. After that, it's a very low-maintenance API. You just have to do some oil changes once in a while. And by oil changes, I mean just call pause and resume when your application gets paused or resumed. And next, you can read the controller state. Now, controller state is probably the most complicated part, because it encodes all of the state of the controller at any given time. So we put together a team of very creative engineers and told them to come up with a way to represent a structure that would encode the controller state. And what we came up with is struct controller state. It's just a struct, and it has data in it. Also, we made the creatively named readState method that reads the state. And it's that simple because it doesn't need to be more complicated. On your drawFrame method, on your rendering logic, you're going to call readState, and that gives you the latest known state of the controller. And then you can process that state in render. How do you do that? Well, the state has fields such as orientation, gyro, accel, and those just mean the current readings of the various sensors in the controller. For a touchpad, we have an is-touching boolean that tells you if the user is currently touching the touchpad or not. And we also have what we call the event booleans, or the transient booleans. And those are the booleans that tell you that a certain event just happened. And those are true for only one frame. So when you render your frame, that's going to be true. Next time you render your frame, it's going to be false, because it just represents something that just happened, like the user has just started to touch the touchpad or just stopped touching the touchpad. And of course, you also have the touch position in X and Y, as we explained before. Button states work in a very similar way. So you have the click button and the app button. You also have the state, and you also have the events. Recentering is what the user does when they notice that the headset and the controller are drifting apart, so they're no longer centered, or when they have just picked up the headset and it's facing the wrong way. So there's a gesture that they can do to make both of them recenter, and that's holding the home button, pointing forward for about 1 second, and then releasing. And then both the headset and the controller will be recentered to the same coordinate system. So before and after. Basically, if before the coordinate system had diverged, after they're both going to be pointing forward. And you can know that the user is recentering by looking at the recentering or recentered variable. You don't actually need to do anything because the coordinate systems are handled by the SDK. But if you want to, you can have access to those variables. You might want to pause the game, for example, when the user is recentering. Next, we have API status. The API status just tells you about the general health of the API. So we have kcontroller API OK, means everything's going well. There's API unavailable if the service is unavailable. Client obsolete if the client is obsolete. Service obsolete if the service is obsolete. And zombie apocalypse if there's a zombie apocalypse and the undead are taking over the planet. Just kidding. That one doesn't exist. The controller will continue to work in case of a zombie apocalypse. Connection state is just whether or not the controller is connected to the phone right now. So there's disconnected, there's scanning, connecting and connected. The best state is connected. And I'll tell you how later, but this has to do with saving the world. More on that later. And you can download the demo app and look at code that actually does all of those things. Let's quickly look at the Unity SDK. In Unity, just as you did before with the Cardboard SDK, you import the Unity package into your Unity project. Once you do that, you'll notice that there's a prefab under Assets Prefabs controller called GVR controller main. And all you have to do is drag that prefab into your scene, and then you have access to the controller API. In Unity, you normally edit things in the editor, and then only after you're happy with it do you actually deploy it to the device. And we support that use case because you can plug in the controller emulator directly to your computer via a USB cable and have it work during the edit mode. And then once you're happy, you can deploy it to your phone, and then it's going to work via Wi-Fi. Let's take a look at an example code. Let's suppose that I have an object, and I want that object to match the pose of the controller. All I need to do is set the object's local rotation to the controller's rotation by calling GVR controller.rotation. It's that simple. Suppose now that you want to have a vector that represents where the controller is pointing at. Again, we just have to multiply something by vector3.forward, and that something is just GVR controller.orientation. That's what you multiply, and then you get a vector that points in the same direction that the controller is currently pointing at. Now let's do some raycasting. Suppose you have a game where the user is trying to select an object in 3D space using the controller as if it was a laser pointer. Again, you just get a vector from the controller and then do the usual Unity raycast to figure out which object was hit. So the API is very straightforward. Lastly, we also have gyro and accelerometer, and those are they're just reported in that format that we described before. And you have the touch, which works just like the C++ SDK. It's touching is whether or not the user is touching currently, and then there's touch down, and then there's touch up. Same thing for buttons, all the same logic. Click button down, click button up. Yes, click is the name of the button. So app button down, and up. And then we have, of course, the GVR controller.state. Same thing, disconnected, scanning, connecting, and connected. Oh yeah, and I had promised to tell you why that has anything to do with saving the world. OK, imagine that you have a game where you're trying to save that nice little planet there that is just exactly like Earth. And suppose that there is this evil enemy. Let's say you're trying to defend it from the moon. That makes no sense. Let's say it's something that's definitely not a moon. So you're trying to save it from that enemy. And just as you are in the final boss battle, the player is about to deal that final blow and save the planet. Then what happens? Of course, the controller disconnects. And then they are sitting there, and they're not able to do anything, and that's the end of humanity as we know it. And because we like humanity, and we should, this is how you save it. Anytime the GVR controller.state is anything other than GVR connection state.connected, that's when you should, for example, pause the game and let the user reconnect the controller instead of continuing to play. So we talked a whole bunch about all the features of the controller. We talked about our SDKs. And again, you can go to developers.google.com/VR right now, and you can download the SDKs and the emulator app if you want, so you can get started developing today. In the beginning, I showed you this, but I actually lied a little bit. That's not 100% true. The only thing that's standing between user and happiness, it's not just code. There's more to happiness than code, surprisingly. You actually need design. And if you're asking what's the difference between code and design, the way I like to think about it is that code is when you're doing the thing right. And design is when you're doing the right thing. So in order to talk to you a little bit more about how to do the right thing, I would like to welcome Ryan and Francisco from Shell Games.
Hello, everyone. My name is Francisco Suki. I'm a game designer at Shell Games in Pittsburgh, Pennsylvania.
And I'm Ryan Hippel. I'm a programmer at Shell Games.
And we spent a little over a month just making cool stuff for the controller, right? We made 17 demos, and our goal was to just play around with the controller, see what feels right. And we were using the same tools that would be available to you today if you were to develop, right? A Nexus 6P and the headset, and an emulated controller and a Nexus 5, and using Unity to make all our games. So we're going to take you through some of the demos that we made that we learned a lot from, and tell you a little bit about the design on my side and the code on Ryan's side. And to start, I will say that, like you heard these guys say, this controller has a lot of sensors, it has a lot of data, it gives you a lot of power, and me as a designer, when I saw this, I was like, this looks cool, I guess. Ryan, you know how to interpret all this stuff, so my vision for this is I have a controller in my hand. Can we just make something that feels to the player like they're holding something, like they're holding the controller?
Of course. How about a game of tennis or a brick-breaking game? Or what if we just combined those two and made a tennis brick-breaking game? So our tennis demo, we're using the orientation quaternion from the controller to control the rotation of a tennis racket that pivots around the body of the player. And we have a very natural range of the tennis racket that way, where you can do your forehands and backhands, and it's always rotated around the right spot. On the more game design side of this, we are focusing on leveraging the very accurate orientation we get from the SDK and using that to make sure that when you hit the balls, you're either directing them upward if you're tilting your wrist up, or down if you're tilting your wrist down, and you can make them go to the left or the right. So in order to do that, we're actually cheating the collisions in this game a lot to make the game easy to hit, and we're actually putting the game challenge in there by forcing the player to use that accurate aim in order to twist their wrist to get the ball exactly at the panel that they want to smash.
Yeah, so like Ryan said, in this game, it's all in the wrist, right? We do a little bit of timing so that if you swing early, it'll go that way. If you swing late, it'll go that way. But you don't have to worry about the position of the ball and how to hit the ball. It's more about your aiming with the wrist. It was very fun. The playtesters loved it, or shall I say, the playtesters that love skill games loved it. The playtesters who maybe aren't fond of tennis or don't like skill games, they weren't so hot on it. So my immediate thought there was, well, why don't we try some more traditional motion, kind of like gesture detection, and see how they feel about that.
Of course. So in our more traditional motion control game, we have our warrior game, which you can see in this video here. Players try to slash at objects before they hit a warrior avatar. And we're using this by actually just detecting a few simple gestures with the controller, and we're using the gyroscope readings here. The gyroscope readings are the perfect thing for this because they're going to tell us how fast the player's moving the controller. So once their movement speed is exceeding some threshold that we need to use, we'll figure out exactly what direction that's going, and we'll quantize that into a left, right, up, or down slash, and use that to power an avatar that has a sword and gets to break stuff.
Yeah, so this works. But you do get a little bit of that kind of like, I'm standing here, swiping effect, right? Which is how every other sword game before has been made in a gesture-based motion control. And our players who had tried the tennis first were like, I want that one-to-one. Why are you giving me gestures? So Ryan, is there anything we can do to this game to get some of that one-to-one back but not compromise the core mechanic?
Yes, there is. This is where we can one-up traditional motion control games because we have that accurate orientation quaternion. So by maintaining the gameplay that we already have with the slash gestures, we can use the orientation to power the animation on this character and the scene. And we use that to blend between several animations or several poses. And the sword on this warrior character should always be reflecting the orientation that a player is holding the controller. Additionally, one issue with our first approach was if you would swipe to the left, you would do a sword slash to the left. But if you're twisting your controller, that's now an upward swipe. So you can get around that by multiplying or by transforming your gyroscope readings by the orientation, which will give you something that's more of a world space slash detection. So no matter how they're twisting the controller, it's always going to slash according to the movement of the player.
Yeah, so you can definitely take those gesture controls to the next level. But I wanted to go back to that one-to-one, to that holding an object in my hand and examining it and trying it out. And I was hoping maybe instead of aiming far away, we could give them, the players, something that's a little more close range to play with.
So in our xylophone demo, we let players play a massive xylophone with a massive hammer. Why not? Here we're actually taking the orientation and splitting it up into different components and treating each of those axes differently. So swinging the hammer up and down, we're using the pitch axis or the x-axis, and that's powering the position or the rotation of the hammer. And we keep a little bit of a constraint on that so it doesn't clip through the keys and it doesn't break immersion. We're using the ability to point, so this would be the heading or the yaw of the controller, in order to aim at what keys the player is going to hit to play what notes they want to play. On top of that, we're using a little bit of the camera's rotation. So you'll notice in the video here that the field of play is much broader than what you can see with just one screen. So turning your head, you can look to the left or to the right. And we're using that to cheat a little bit and make sure that the player is going to hit the thing that they're focusing on so that when they're moving their hand quickly, they don't end up throwing off the direction of the hammer. So we're doing a little bit of aim assist in this game.
Yeah, and in this demo, you can tell the players are starting to feel things start to gel, right? They love manipulating a closely held object, And you can usually, as a game designer watching them play, watch them go through 3 stages. The first stage is they jump in the world, they see they're holding a hammer, and they do the wrist thing. And the hammer does a wrist thing for them. So that's great. The controller is working perfectly there. Then they realize the keys are in a curved shape, so they look around. Right? So they're using that sort of VR space, looking all around. And then they identify any key they want to play, and they go for the boop, and it works. Right? So it's a combination of where you're looking and how you're swinging. And when that feels right, and when the world holds up to what they want to do as players, it feels great for them. And then that's where the platform really shines. So that combination of head orientation and controller action helped improve their perceived accuracy. And so I'm thinking, well, can we use that combination of that aiming and that closely held object to maybe let them do something that they wish they could do, but they can't do in real life?
If anybody's here actually tried to throw a boomerang, has anybody ever tried to throw a boomerang? It's incredibly disappointing. There's a very, very, I guess, powerful technique that is only mastered by a few. It's really sad. You throw it, it doesn't come back, it doesn't go where you want it to go, it just kind of wobbles around. But there's this expectation of what a boomerang does. You see that shape and you feel like I should be able to throw this, it should be able to go exactly where I want it to and have it snap right back to me. So this is where we take the orientation that we get from the headset, again, and we use this as an aim assist. So where the player's looking in this demo is going to drive where the curve of this boomerang goes. And the goal here is to break as many of these floating targets at once with a single throw to kind of get that ideal path. So since we're using the head for aiming, we now have the controller free to do our throwing. And we're using the similar thing we did for the sword slashes here, where we're using the gyroscope readings, and if it's above a certain threshold, it's going to trigger the throw. So just looking where you want to throw and doing your throw gesture is going to get that boomerang out there. Additionally, to maintain a little bit of immersion here, we're using the orientation to make sure the boomerang rotates to reflect the rotation of the controller, at least when it's in your hands. And you can see that in the videos here, just that little bit of ambient movement just is keeping it, grounding the player between the two worlds.
Yeah, so like Ryan said, this video is about empowering the player and about letting them experience their boomerang fantasy, how they feel it throwing a boomerang should feel like, right? So it's all about like, boom, I want to put it in that exit sign, bam, it's going there, right? So less about very precise one-to-one matching of the thing they're pointing at or the exact hand movement, and more about the precise matching in the boomerang in their hand combined with the aim assist that the gaze is providing us. So it's all about kind of interpreting all of those, all that data that we get, and letting the player sort of fulfill what they think it should play like. What we realized at this point, though, is we hadn't touched touchpad at all. It was all about the swinging and all about the pointing and the head. And touchpads are just the #1 thing usually used in games, right? Whether it's a joystick, a virtual touchpad. So we're like, we use touchpads all the time for all of our games. Can we just put something we would normally make in a normal platform, a different platform, a non-VR platform in this special place with this touchpad? Does it hold up?
Of course we can. Using the touchpad that we have on the controller, we can use that as a traditional D-pad controls. And this is something that players are going to be immediately familiar with because it's the type of games that have existed since, well, almost the beginning of games. So in our adventure game demo, the player controls a little character walking around using that D-pad. And the nice thing about this is it frees up the headset now functions as your camera control, which is generally a little bit of a problematic control scheme in adventure games. So you can look around the world, and it adds this sense of exploration that you can see more than you would be able to if you had to have this automatic follow camera. Those controls then also, we have them a little bit specialized for the layout here. We're able to have this character and an environment, it circles the player and their perspective. So when you want to move the character along that path, we have it so that it's almost a circular-based path. You hold to the right on the D-pad, and this player is going to trace a circle, or the character will trace a circle around the player, making it much easier to navigate, making it easier to make the player move forward through the world. And of course, in this demo, we have it end up with the player meeting the character they've been controlling this entire time.
Yeah.
We also use a little bit of the gesture controls that we talked about before and the click pad in order to use abilities that can trigger things in this environment and have some light puzzles and some collection mechanics, as you can see.
Yeah, so boy does it hold up, right? Like when you're making your own adventure games, you will realize that you can use a touchpad for movement, no problem. It's going to feel great. And that's going to free up all the other stuff in the controller for you to explore that space. So this is the extent of the demo that we made, right? Everything you're seeing here is the totality of the spaces we explored. So what that leaves is a lot of open space for you guys to sort of take it to the next level however you feel like you want to. So in this case, the click, the gestures, the pointing, all that is still freed up. It's not something that you need to use, and the touchpad feels familiar to the players. It's recognizable, so you truly can use all of those interactions because the player doesn't need to think twice about how to use a touchpad to move a character. Ryan, where did we take it after we figured out that the touchpad was good for one character?
Well, if it's good for one player, let's see if we can use it to control multiple characters. So in our real-time strategy style demo, we're using the orientation quaternion that we get from the controller, from the SDK, and using that to raycast into the world. And you can use this to point to select a character and then point to direct them somewhere. And you can also drag select to select multiple characters in the world and give them instructions at the same time. You can also use gyroscope gestures again, like we did for the sword slash and like we've been doing for a lot of the games, to trigger multiple actions that these characters can do. And in this, we have a few simple puzzle mechanics that lets the player explore this world. And again, you're using the orientation from the headset and taking control of the camera very naturally with just the player's look vector.
Yeah, and boy, does point and click feel good in this platform. We love this demo. Playtesters love this demo. People couldn't put it down until they figured out the full puzzle that we had. And the interaction was just empowering them to control the characters how they wanted to control the characters. We also draw a line from the assumed controller position to the target, and that keeps players aware of the orientation of their controller at every time. And that interface does make it really easy for you to control one character or several characters. And similar to the adventure game that you just saw before, the touchpad game, it frees up a lot of the controller, especially because you can also use the whole world, the whole 360 around the player to sort of pace out your level and to control where the player is going to be looking at any given time, so that camera movement doesn't need to be tied to the controller in every way. So if your mind right now is going like, man, how can I use a mechanic to make an RTS or to make a strategy game, a tactics game, any sort of multi-character control game with that drag to select and all that, that's exactly where it should be going because the platform is really good for it. What we thought, though, was, well, we figure out how to sort of get the most of those orientation controls, how to get the most of the character control. Can we marry those two together?
Of course we can. In our Skyship demo, the players control a gliding airship through an environment where they're dodging obstacles and trying to pick up coins along the way. This is actually pretty simple on the input side where we're just using the orientation that we get. This lets us essentially just point and click, or I'm sorry, no clicking, point to guide this glider around the environment and using the yaw, the pitch, and the roll, just like you would with an actual aircraft to get it to move around this environment. Having the roll or the twist as well is really nice for this because should the mood strike you, you can do a barrel roll.
Yep. And Ryan said no clicking because, again, the clicking is freed up here for you to do whatever you might want to do on a flying ship. When you play this, it really feels like you're kind of handling a toy airplane, right? You're kind of like threading it through space, all through these rings. The handshakiness is not a big problem here because you control how wide the gaps are with the rings or the spaces that you're trying to fit the spaceship through or the ship through. So that kind of counters a lot of the imprecision that your own hand translates into the world. And it does allow you to orient the ship sort of however you want as you're flying with it, right? This is another one that playtesters couldn't put down. We just keep the rings coming, and they will keep playing. And so like unless you give them a goal of like collect 10 coins and then please pass it along, they will just like stay in there doing it all the time, right? It feels good. The pillars are there so that you don't get that motion sickness from moving forward. You're stationary, the world's moving in front of you, so you're fine. You don't get that motion sickness. And at that point, we're feeling pretty confident, and we're like, all right, we seem to have this flying thing figured out. It's constrained to a plane, but maybe we can break out of that plane. Maybe we could go a little bigger. What I want to do is I want to feel like, not like I'm flying a kite, but like I'm controlling this giant creature that I just summoned.
Here be the dragons. In our dragon demo, the player controls a massive dragon using, again, the controller orientation. and they're pointing the controller in the direction that they want the dragon to go. To give a little bit of an immediate feedback, we have a little doll or a statue of the dragon positioned in front of the camera so the player can see what the goal orientation is. And this is another thing that we've learned in the other demos, where we want to maintain a relationship between the controller and some physical object in the environment. Then in order to make the dragon feel like it's this massive entity, we have that point towards that vector that you're guiding it towards and have it sort of lumber along and this long twisting path, collecting and destroying those floating objects.
Yeah, but this one feels really good. When you get the source to play with all of these, just fire up this dragon demo, point the controller at yourself, and watch a dragon come at you. And we've added a bunch of things in there that sort of like take advantage of that VR, right? There's a slight camera shake, which sounds kind of like, what, you're shaking the player's camera? But don't let anyone ever tell you what you can't do in VR. Try it and see if it works or not, because it works here, right? It's a slight shake. It's combined with the positional audio of the dragon, so that you really feel like you're sharing a space with this big creature. And you're kind of doing this dance with it. It's big and it's heavy, and it handles like a big, heavy creature. So you're kind of like dancing with it through space, right? And you're trying to eat up all these big structures, and then you point it at yourself, and it's coming at you, and there's this thing next to you, and it tries to eat it, and you're like, oh my god. It's great. It feels really good, right? This is really, I think, showcasing what the Daydream can do, which is a lot. But especially when you combine the headset with the controller and you get those epic flyovers with the dragon, it feels great. So at this point, we're like, all right, I mean, we did the dragon thing, the boomerang thing, the xylophone to play the music, a bunch of other stuff. We have 17 in total. And what's left for us to do? Should we really give the people what they've been asking for all along?
You've seen it already. You've seen it plenty. Here be the pancakes. In this demo, we're actually using the orientation to flip these pancakes, and then we have a very advanced pancake physics engine that we're running to make sure the pancakes are moving around as they should. Well, in reality, it's actually just using the basic game physics system here and having a pan that has the lip on it as the collision structure. It actually works really, really well. This orientation gives you that really nice flip gesture that you can do, and we're not really doing a gesture detection. When I say gesture, it's just sort of natural how the physics simulation pairs up with having this raw orientation input. And it turns out to be a very, very fun thing to do. We did do a little bit of active pancake assist here to make sure the pancakes don't get out of reach. But overall, it's just a very natural, fun demo.
Yeah, and I do think the pancakes sort of fit what is awesome about Daydream, which is you see the pancakes demo, you've been reading, like people are tweeting about it from the keynote and all. It's like, oh my god, I want to flip pancakes in VR. And you get in there and you flip pancakes in VR, and it plays how it looks. You're flipping pancakes in VR, and you're like, yes, got it. So when the platform allows you to do exactly what it looks like, and it feels like what it looks like and what it should feel like, that's when you know it's a big win. So over to Ryan for some final thoughts on developing all these awesome demos.
What if we could eat pancakes in VR?
That's the next step.
Francisco mentioned at the beginning of our section that we built 17 demos, so 17 demos like these, and we did that in a little over a month. All of the tools that we had to do this were the SDK that Bruno and Bashir talked about, and using the controller emulator, where you're actually using a phone as your input device, and a Nexus 6P we were using a cardboard to develop with. So all of these things are out there, and they're available now, and the source code for all of the demos that we've built should be available soon for people to play around with and use as a starting point to jump in and start making great games with this platform. We really feel like the things that we put together only really scratch the surface of what we can do with Daydream and what we can do with this amazing controller. So what will you build? Thank you.
Thanks.